Okay, these are the notes for today. They're on theoretical probability. You should have out to take notes with you this sheet right here. It's a theoretical probability notes, page 1. So that is where we are starting, and just follow through along with that. Like I said, you should take the notes with it, do what I do, and then your homework will be practice B and C. Okay, so theoretical probability. We're actually going to go down to the bottom of the page first. So the difference between experimental and theoretical probability is that experimental probability is what does happen. So when we did our stations last week, and you flipped a coin 20 times, or you rolled a die 20 times, your experimental probability was how many times you landed on a certain thing, like say a 2 in die rolling over 20. So that's experimental probability. It's what does happen when you test the game or whatever it is you're doing. Theoretical probability, if I can spell it correctly, is what should happen. So oftentimes we will see that these are not the same thing. What should happen and what does happen when you do the experiment are two different things. For instance, when you rolled a die 20 times, you could have landed on 5 all 20 times. But in theory, you're only going to land on a 5 1 out of every 6 times. Okay, so back up to the top. Theoretical probability is the number of ways the event can occur divided by the total number of equally likely outcomes. We already know this. We've already talked about this with dice rolling and stuff. I already asked you what's the probability of rolling a 2 for a die, and you know it's 1 out of 6 because there's one way to roll a 2 and there are 6 possibilities. Now what we have to be concerned about, and you will also have to be concerned about it with your project, your carnival project, is this concept of equally likely outcomes and fair games. Equally likely outcomes means there's the same chance that every outcome will happen. In this instance, it's the same chance that the spinner will land on any of the colors, because these are all angles of equal measure. So the yellow is the same size as the blue, is the same size as the green, is the same size as the red. Now in this one right here, of course, that blue is so much bigger. So you have a 50-50 chance of landing on blue, and the rest of these are different. The green and the yellow are the same size. The red is a little bit bigger. So there's a greater chance that the spinner will land on blue than any other color. So that is not an equally likely outcome. If you have equally likely outcomes, then your game is said to be fair. Equally likely examples: coins, fair die, of course, die that aren't like weighted to one side or another. This spinner, like this one right here, with all the same possibilities, a fair deck of cards, that kind of thing. Not equally likely outcomes would be, of course, a spinner like this one right here, like a two-headed coin at the carnival games where you have to shoot a basket. I know you guys always like my artwork, so there you go. But you need to shoot a basket, you have to get a basketball in there, but the basketball is actually bigger. I think that's what a basketball looks like, than the hoop. So that would, of course, not be, those would not be equally likely. They wouldn't be a fair game. So that's the kind of thing. What you have to make sure with your carnival game is that you do have equally likely outcomes. That, you know, if the goal is to land on red when you roll a cube that has red, yellow, green, blue, but it has red, 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 yellow, green, blue, then of course it's not equally likely. Okay, moving on. So with probability, if you see this, P and then parentheses next to it, it means the probability that an event will happen, and the event goes in there. So, for example, with dice, P of 5 reads the probability of rolling a 5. So if we're going to go over here, we have an experiment consisting of rolling a dice. Find the theoretical probabilities of each outcome. Well, P of 5, I have one way to roll a 5, and I have 6 ways, 6 possible outcomes. So it's 1 over 6. For evens, probability of rolling an even number, of course, we have 2, 4, and 6. There's 3 of those, so it's 3 over a possibility of 6. Of course, we want to reduce that to 1/2. P of 2, one way of getting a 2, 6 possibilities. P of 3 is going to be the same thing. Now we're moving over here to an experiment containing a deck of cards. Now, in case you're unfamiliar, there are 52 cards in a deck, 26 red, 26 black, and there are 4 of each type of card, because, you know, I'm talking like ace, 2, 3, and so on. You have hearts, diamonds, spades, and clubs. Of course, spades and clubs are black, hearts and diamonds are red. And so there's different ways to do this. So we have to find the theoretical probabilities of each outcome. Well, probability of drawing an ace. I have an ace of diamonds, I have an ace of hearts, I have an ace of spades, and I have an ace of clubs. So there's 1, 2, 3, 4 aces, total of 52 cards in the deck. So it's 4 out of 52, which reduces to 1 out of 13. The same thing can be said for the probability of picking a 2. I have the 2 of diamonds, the 2 of hearts, the 2 of spades, and the 2 of clubs. So I have 1, 2, 3, 4, 4 out of 52, or 1 out of 13. Probability of a face card. We did this in our experiment. We have Jack, Queen, and King. But of course we have Jack of diamonds, Jack of hearts, Jack of spades, Jack of clubs, and same thing with the King and the Queen. So we have 3 of these, 3 Jack, Queen, King, 4 possible suits for each one. So that gives us 12 out of 52, which then reduces to 3 out of 13. And then over here we have probability of not a face card. Well, here's the thing. You're either a face card or you're not, right? We already talked about this. So if the probability of a face card was 12 out of 52, I can just take 52 minus 12. I'll get 40, and I'll have 40 out of 52, which reduces to 10 out of 13. And that's this concept at the bottom. It says take a look at probability face card, probability not face card. What do their probabilities add up to? Well, let's take a look. We have 12 out of 52 plus 40 out of 52. And we've made mention of this in class before, so you might already know it. 12 plus 40 is 52. Of course, that's not 104. That's still 52. So 52 over 52 reduces to 1. If we're thinking percents, it's 100%. And explain why you think this is the case. You already know why this is the case. You either have one outcome or the other. So your probabilities have to add up to 1. Or 100%, if you want to say it that way. And this is always going to be the case if you've taken every option. So if the only options are face card or not face card, then it's going to be 100%. Okay. Now, this illustrates what we just said. So the probability of an event happening plus the probability of an event not happening is 1 or 100%. So it either happens or it doesn't happen. Probabilities of an event and its complement, which of course is when it doesn't happen, has to equal 1 or 100%. So let's take a look. We have 3 more examples here. So a box contains only red, black, and white blocks. Probability of choosing a red block is 1/2. Probability of choosing a black block is 1/4. What's the probability of choosing a white? Well, I know that 1/2 plus 1/4 plus P of white has to equal 1. You might just be able to do this in your head, of course, knowing that 1/2 and 1/4, you could change them into decimals if you like, or you can make this 2 out of 4 plus 1 out of 4, plus the probability of white is 1. 2 plus 1 is 3, so we have 3/4 plus the probability of white equals 1. 1 minus 3/4 is going to give us 1/4. So the probability of pulling a white block is 1 out of 4. Alright, number 2. A jar has green, blue, purple, and white marbles. Probability of choosing a green marble is 0.2. Probability of choosing a blue marble is 0.3. White is 0.1. What's the probability of purple? Well, same thing. 0.2 plus 0.3 plus 0.1 plus, plus probability of purple has to equal 1. Well, if you add all these up together, that's 0.6 plus the probability of purple equals 1. If you subtract 0.6 from both sides, then you end up that the probability of pulling a purple is 0.4. Alright, with this last one, I will help you out right here. This totals 98. There's always 2 blanks. So really it's 100 in a Scrabble bag, but we're not counting the blanks in here. So the distribution of letters in Scrabble is the table at the right there. Find the probability of choosing a vowel and the probability of not choosing a vowel. Don't include blanks. Well, we didn't. So probability of vowel, just in case we are not that great at English, we have A, E, I, O, U. We will count sometimes Y, just so he doesn't feel left out. So probability of pulling a vowel. There's my A's, E, I, O, U, Y. So we have to add these guys up. So we have 9 plus 12 plus 9 plus 8 plus 4 plus 2. So that's going to give us a total of 44. So it's going to be 44 over my entire possibility of Scrabble blocks, which are 98. Of course, those are both even. That can reduce. It is 22 over 49. If you're a percent person, it's about 45%. Now, probability of not vowel. You do not have to add all of these up. That would take forever, and it would be a complete waste of your time. So instead, we are going to take 44 and subtract it from 98. Or actually, if you want, it's probably easier to take 49 and subtract 22 because it's already reduced and it's a little bit smaller of a number. So you end up with 27. So it's 27 over 49 for not pulling a vowel. Okay, that's going to be tomorrow. We're going to play Let's Make a Deal with Monty Hall. But for today, this is the end of this. Your homework, like I said, is practice B. I believe it's 10-6 is the section. And practice C. They are a front and a back. When you are done, take some time to, so this is number 1 that you have to do. Number 2, you're going to work in your groups, your pairs for your carnival game. My expectation that you will have done with this tomorrow is that you will know what your game is, and who is responsible for what part. Okay. I don't know how long you'll have to work on this, Plan on about 10, 15 minutes in class tomorrow to work on it too. All right, good luck.